This is a video to help you with your target test for scientific notation and exponents. Scientific notation is used to write really big numbers or really small numbers. It's a great tool to use those. The numbers I have up here are 7,500,000, 3,800,000, and if I look at this, this is my tenths place, my hundredths, my thousandths, my 10,000ths, and my 100,000ths. So I would say that as 2,600,000ths. Those are all numbers that would be great to use scientific notation for. What I'm doing in the top half is I'm converting numbers from standard notation to scientific notation. And standard notation is the way we see numbers most of the time in a math class and around the world. But like I said, sometimes scientific notation is a really nice way to show really big numbers or really small numbers. Here's how you use scientific notation. If I have the number 7,500,000, I'm going to write that as a number between 1 and 10 times a power of 10. Okay? And what I mean by that is I have to move the decimal point and then multiply it by a power of 10. So if my number is 7,500,000, the first thing I have to do is I have to write this so I have a number between 1 and 10. I have to move the decimal point so I have a number between 1 and 10. To do that, I have to move my decimal point all the way over here. I want one non-zero number to the left of the decimal point. So in this case, it's going to be 7.5. Okay? That's the first half of scientific notation. Now I have to multiply that by a power of 10. So it's going to be times 10 to some power. Now if the numbers are really big, I'm going to have a positive exponent for my base 10. If the numbers are really small, like 2,600,000ths or 4,100,000ths, I'm going to have a negative exponent for my base 10. So the exponent is also how many spaces the decimal point has to move. So in this case, my decimal point starts there on numbers. It starts after the ones digit. And then I have tenths, hundredths, thousandths. But my units digit, it starts right after that. That's where my decimal point starts. I have to count how many places my decimal point has to move to get between the 7 and 5. It's important that you realize it's not the number of zeros, but it's how far the decimal point has to move. In this case, it moves 1, 2, 3, 4, 5, 6 places. So in scientific notation, 7,500,000 is 7.5 times 10 to the 6th power. It's to the 6th power because the decimal point moves 6 places. Let's try another one down here. We're going to try number 4 and do that one. So I start by moving my decimal point so there's one non-zero number to the left of the decimal point. So I've got to move it between the 4 and the 1. So I'll write that down. 4.1 times 10 to some power. Now in this case, since it's a small number we're talking about 4,100 thousandths, I'm going to have a negative exponent. And the number for the exponent is how many decimal spots, or how many decimal places the decimal point has to move to get between the 4 and the 1. So it starts here, so let's count how many places it has to go. 1, 2, 3, 4. So it's going to be 4.1 times 10 to the negative 4th power. Okay? Now your job is to do the other 4. I want you to do 2, 3, 5, and 6. And when you've done with them, then we'll turn on you can pause the recording right now, and when you get done with 2, 3, 5, and 6, then you can turn it back on and check your answers. So right now, pause the recording. Okay, let's check and see how you did. So the first problem, we'll start with 2. I have to move the decimal point from there to between the 3 and the 8. So I'm going to write 3.8 times 10 to some power. Now I've got to count how many spots the decimal point has to move. And since this is a big number, my exponent is going to be a positive number. So it's got to go 1, 2, 3, 4, 5, 6. So it's 3.8 times 10 to the 6th power. The next one is a really small number. So I have to move the decimal point so it's between the 2 and the 6. So it's 2.6 because I have one non-zero to the left of the decimal point. And it's going to be times 10 to some power. Now since it's a small number, it's going to have a negative exponent. So it's got to go 1, 2, 3, 4 spots. So it's 2.6 times 10 to the negative 4th power. The next one, I've got to move my decimal point from here to between the 6 and the 5. So it's 6.5 times 10 to some power. Now I count how many places the decimal point moves. It goes 1, 2, 3, 4, 5, 6, 7 spots. And since it's a big number, it's 6.5 times 10 to the 7th power. The last one, I've got to move my decimal point all the way between the 7 and 9. So it's 7.9 times 10 to some power. And now I count the decimal points, or the places the decimal has to move. 1, 2, 3, 4, 5, 6, 7, 8. So it's 7.9 times 10 to the negative 8th power. And those are your answers for numbers 2, 3, 5, and 6. Now, sometimes it's nice to convert from scientific notation to standard form. And numbers 7 through 12 are problems where you do that. So let's look at these really carefully. When I'm doing this, I'm just looking at the exponent and seeing if it's positive or negative. If it's a positive exponent, then I've got to the number's got to get bigger. So I've got to move the decimal point to the right. If it's a negative exponent, the number's got to get smaller. So I've got to move the decimal point to the left. The number is how many spaces I have to move it. So if I'm trying this one, my decimal point starts between the 2 and the 5. Well, it starts there. I can move it one spot there, but I've got to move it 5 more spots. The problem is I don't have any more places to move it. So what I have to do is add zeros. So let's add some zeros here and see where it has to go. So it starts there. I have to move it a total of 6 spots. 1, 2, 3, 4, 5, 6 spots. So my decimal point has to go there. So it's going to be 2, 5, 0, 0, 0, 0, 0. Is that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. So it's 2,500,000. Okay? The next one, the decimal point starts between the 4 and the 7. Now, I have a negative exponent, so it's got to move back to the left. The decimal point's got to move left 6 spots to make it smaller. Well, I can move it 1 spot really easily, but I have to move it a total of 6 spots. So I'm going to have to add is 5 zeros so I can move it 5 more spots over there to the left. So 1, 2, 3, 4, 5. Now I go 1, 2, 3, 4, 5, 6. So my answer should look like that. Okay, now go ahead and finish 9, 10, 11, and 12 and see if you can do those on your own. So stop the video now and try and do 9, 10, 11, and 12. Okay, let's see how you did. For this one, we had to move the decimal point over 4 spots to the right because it got bigger. So it starts between the 9 and the 3. So I go 1, 2, 3, 4. So it's 93,500. The next one I have to move a total of 5 spots, and this has to go to the left because it's got to get smaller. 1, 2, 3, 4, 5. So it's tenths, hundredths, thousandths, 10,000ths. This is going to be 46 millionths is the way I say that number. The next number, I have to move the decimal point 7 spots to the right because it gets bigger. So I go 1, 2, 3, 4, 5, 6, 7. It's not the number of zeros, it's how many places the decimal point moves, remember. And the last one starts here, and since it's a negative exponent, it's got to go, it's got to move 6 places to the left. 1, 2, 3, 4, 5, 6. So I get 0.0000087. Okay? Now let's try some of these and write each power of 10 in standard form. When I have a 10 to a positive exponent, the exponent is just going to be the number of zeros. Because 10 squared, if I'm looking at 10 squared, that's equal to 10 times 10 or 100. If I have 10 to the 3rd power, it's going to be 10 times 10 times 10. Well, 10 times 10 is 100, times 10 is 1,000. So when I have a positive exponent, I write it, so I just count the number of zeros, and that's the same as the exponent. So in this case, 10 to the 5th power, I'm going to have 5 zeros. Okay? I can do that for any positive exponent. If I have 10 to the 1st, I'm going to have just 10, just 1 0. If I have 10 to the 0 power, that's just going to be 1. And now for the negative ones, I just have to find out how many numbers are to the right of the decimal point. So if I have 10 to the negative second, I've got to move my decimal point 2 spaces over to the right. And I have 2 numbers to the right of the decimal point. So 10 to the negative second is 0.01. Notice I have 2 numbers to the right of the decimal point, and I have a negative 2 as my exponent. So that's all I'm doing for these. So go ahead and try 15, 16, 17, and 18, and then we'll check them in a little bit. Okay, hopefully you stopped the paused and finished off 15, 16, 17, and 18. So when I do this, it's a positive exponent. I have to have 8 zeros. So I just write the 1 down and write 8 zeros. And I put commas every third number starting at the right. So that's 100 million for that one. This one's going to have 2 zeros. So I put a 1 down and then 2 zeros. This one's going to have just 1 zero. So it's just going to be 10. Now this one's going to have negative fourth. So that means I have to have 4 numbers to the right of the decimal. Well, 3 zeros and a 1 make 4. So that's going to be 0.0001. Okay? Now we'll try the last section. Now for these, I have to write them in base 10. So it's just the same way that we did before. I'll do the first one. I count the zeros if it's a big number. So this has 3 zeros, so it's just going to be 10 to the third. This has 4 numbers to the right of the decimal point, so it's going to be 10 to the negative fourth. Okay, I'm going to have you pause the recording and go ahead and do 21 through 24 and see if you can do those. Okay, let's see how you did. So big numbers, I just count the number of zeros. So this is going to be 10 to the 1, 2, 3, 4, 5, 6, 7. So it's going to be 10 to the 7th power. Small numbers, I count to the number of numbers to the right of the decimal point. So this is going to be 10 to the 1, 2, 3, 4, 5. So it's 10 to the negative 5th. This is also going to have a negative exponent since it's a real small number. It's going to be 1, 2, 3, 4, 5, 6, 7. So it's 10 to the negative 7th power. And the last one's a big number, so it's going to have a positive exponent. So I just count the number of zeros, so it's 10 squared. So now that you've done those, you can bring it up to Mr. Petterson and show him that you did all these problems and that you understand it, and then you can take the retake on the scientific notation target test.